Ladies and gentlemen, this is Mrs. Bracy with your video on dilations. What I have here is flashcard number 15, which explains dilations, a figure which is shrunk or enlarged by a scale factor through a center, and the center will be a point, just like a rotation. Dilations are not rigid motions. As we know, they will change the size, but they do create similar figures, which means the angles are in fact congruent, but the sides are in proportion. As you can see over here, I drew a little picture where we have a triangle with sides of 2, 3, and 4, and sides of 4, 6, and 8. And so the sides in proportion means that if you compare 2 to 4 as a ratio here, that will be equal to the comparison of 4 to 8 because those are corresponding sides over here. And to construct, here's the steps. We're going to connect the vertex to the center and extend it out. We're going to measure the distance and use the scale factor to get the new distance. I think you're going to find this to be the easiest of the constructions. So what I would like you to do is to pause the video and copy the flashcard instead of me writing it out with you. That'll save a little bit of time on the video. So do that. And then when you unpause, we're going to do some pages out of your packet. Okay, so let's go to page 31 in the pink packet, and we're going to construct the image of triangle RST after a dilation centered at C with a scale factor of 2. So following the steps given on the flashcard, which are also at the bottom of this page, which I can't fit on the screen right now, we're going to connect the center to any of the vertices, and we're going to extend it out because we're going to double the length. That's what a scale factor of 2 is going to have us do. So I'm going to connect C to R, and I'm going to extend that out this way. Now what I'm going to do is with my compass, I'm going to measure the distance from C to R, and as you know, when we measure it, we mark it, okay? And then you're going to copy that distance at the end of that vector or ray from R out here. So we have doubled the distance from C to R, and this is going to be R prime. Okay, so the distance from C to R has been doubled from C to R prime, and that's your new point. We're going to do the same thing for T and for S. So I'm going to connect them both at the same time here to save a little bit of time. Remember, you're doubling the distance, so we want to extend it out nice and far. Okay, we're going to measure from C to T. Okay, measure and mark. Put the tip of the compass at T. Mark it out here, and you have T prime. And then one more time for S. Measure from C to S, put the tip of the compass at S, and extend it out. If this is going a little bit too fast for you, don't forget you can always pause in the middle and get caught up. We're going to go ahead and connect the 3 vertices, and since our scale factor was 2, it should appear that the new triangle R prime S prime T prime is twice as big as triangle RST. Okay, and so notice again, these distances from C to S was doubled from C to S prime, and C to T was doubled from C to T prime. Okay, so that's what a dilation looks like. Let's flip the page and do another one. So this is page 32. We're going to dilate math centered at C with a scale factor of 1/2. So we're going to have to cut the distance in half. So this time we don't need to extend this out. I'm going to connect C to H to begin with. It doesn't matter what order you do these in. And how are we going to cut a distance in half? Hopefully that makes you think of a bisector. So we're going to draw the perpendicular bisector of this segment. Make sure your compass is nice and wide here. This one's going to have a lot more construction marks than the previous one. Okay. And when you construct that perpendicular bisector, remember you're constructing the midpoint here, and that's going to be your H prime. So we just cut the distance from C to H in half to get C to H prime. Okay, we're going to go ahead and do that for all of the vertices again. So from C to M, from C to A, and from C to T. So what I'm going to do is I'm going to pause the video, I'm going to finish this, and then I'm going to show you what it should look like. Okay, so when this pops back on, you should pause the video as well. You can finish this up. When this comes back on, you'll see what this should look like at the end. New trapezoid looks like it's about half this size. It's the purple one there. All right, one last thing is to find the center of the dilation. And again, this is going to be a very easy one. We're just going to connect each point to its image And we're going to extend that line out nice and far. So if we do this to 2 different points, the point where those lines hit will be the center of dilation. So I'm going to do that with D and F. And now I'm also just going to show you, if you also do this with E, you can see that all 3 of them meet. Whoops, that kind of went off the page a little bit there. You can see they all meet there, and this would be your center of dilation with a scale factor of 2. So you can see that the figure is doubled. And that's it for dilations. I'll see you in class.